In this week, we are going to be talking about probability. I welcome you to this first session on probability. In this session, we'll basically give an introduction to probability, also talk about probability distribution, and also how to calculate probabilities and how to calculate parameters of a random variable. A random variable is any characteristic that can potentially take more than one value. It can either be binary, e.g. male or female, categorical, e.g. blood group A, B, AB, and O, or numerical variable, e.g. the number of people with a disease. Statistics has two branches: descriptive statistics that deals with describing, summarizing, and presenting data in order to show patterns in the data. We have covered this in learning in public health. On the other hand, statistical inference deals with making conclusions about population parameters. These are population mean, mu, population proportion, pi, population standard deviation, sigma. We do this using data from a sample. We will cover statistical inference in this course, and it is important to understand probability before we start on statistical inference. Probability is a number between 0 and 1 that estimates the chance of an event happening. It ranges from 0, indicating an impossible event that would never happen, to 1, which indicates a certain event that would definitely happen. As an example, from a group of 6 men and 4 women, the probability of selecting a woman is 4 out of 10 or 40%. A probability distribution for a random variable gives the probability for each value of the random variable. It can be in form of a table as shown in this slide, or in form of a formula. As an example, consider the data given in this example in this slide for a random variable age in years. There are 2 people aged 40 years, 1 aged 41, 4 aged 42, 2 aged 43, and 1 aged 44 years. The probabilities for each age, denoted by P of x is equals to x, representing probability of x is equals to x, are given in the table. For instance, probability of x is equals to 40 is 2 over 10, probability of x is equals to 41 is 1 over 10, probability of x is equals to 42 is 4 over 10, probability of x is equals to 43 is 2 over 10, and probability of x is equals to 44 is 1 over 10. Please note that the 2 properties of a probability distribution for a random variable are satisfied here. Number 1, every probability lies between 0 and 1. As you can see, all these probabilities, 2 over 10 until 1 over 10, they lie between 0 and 1. Number 2, the sum of all probabilities is 1. In other words, 2 over 10 plus 1 over 10 plus 4 over 10 plus 2 over 10 plus 1 over 10 is 1. The probability distribution can also be represented graphically as shown in this slide. We can use the probability distribution to calculate probabilities for a single value. E.g., probability of x is equals to 40 is equals to 2 over 10, which is equals to 0.2. Or for a combination of values. For example, probability of x greater than 42, which is the same as probability of x is equals to 43 plus probability of x is equals to 44, which is equals to 0.2 plus 0.1, which is equals to 0.3. Probability of x less than 43 is equals to probability of x is equals to 40 plus probability of x is equals to 41 plus probability of x is equals to 42, which is equals to 0.2 plus 0.1 plus 0.4, which is 0.7. And lastly, probability of 42 less than x less or equal to 44 is simply equal to probability of x is equals to 43 plus probability of x is equals to 44, which is 0.2 plus 0.1, which is 0.3, as shown in this slide. Now we move to the parameters of a random variable. These are the population mean mu, population variance sigma squared, and standard deviation sigma. This can be calculated using a probability distribution with formulas given in this slide. So for the mean equals to mu, it's equals to expected value of x, which is equals to sigma, which represents the sum of x multiplied by its probability of x is equals to x. To get the variance, which is denoted by sigma squared, is equals to v of x, which represents variance of x, is equals to expected value of x squared minus expected value of x to be squared, where expected value of x squared is a value squared multiplied by its probability and then taking the sum represented by sigma. Then to get the population standard deviation, we simply calculate the square root of the variance. So for the example above, we are going to have mu is equals to 40 multiplied by its probability 2 over 10 and so on, and then we get 41.9. To get the expected value of x squared is 40 squared times 2 over 10 and so on, and then we get 1757.1. Then to get the population variance, we simply take the expected value of x squared minus the mean squared and we get 1.49. And then to get the standard deviation, we are going to get square root of 1.49, which is equals to 1.22. In summary, we have defined probability as a quantity that measures the chance of an event. We have also defined a probability distribution as a table or formula that gives the probabilities for each value that the random variable can take. The probability distribution can be used to calculate probabilities as well as the population parameters of the random variable, namely the population mean mu, the variance sigma squared, and standard deviation sigma. For any questions or clarifications, you can contact me on the email given in this slide. Thank you.